Okay, so here we're going to be following M note 9.6, and we're trying to understand how to get from the best response of firm I to the Nash equilibrium in oligopoly. Now to do that, we're going to go back to the best response function for firm I, and we saw that that was xi in response to x minus I, and that was equal to p bar minus c all over 2 beta minus 1/2 times x minus I. Now, here's the thing. We're going to have to use something that we know is a kind of property of the Nash equilibrium here. So remember that in the construction of this problem, we know that the firms are identical. Okay, so the firms are identical here. They all face the same inverse demand function for the good that's being produced. They're producing homogeneous good x, and they all have the same costs. What that means is that in equilibrium, the outputs for each firm, so for example, xi, and if there were other firms, say xa, xb, and so on, those are going to be equal. xa, xb, x. I'll skip c because that's going to get confusing for the cost, but xd and so on. Those are all going to be equal. Now, if that's the case, what has to be true? Well, it means that the outputs of all the other firms are going to be the same as the output of firm I. So, if that's the case, if the outputs of all other firms are the same as the output of firm I, that means we can think about this thing x minus I in another way. So remember that x minus I, that is the output of all firms that are not firm I. So how many firms are there contained in x minus I? Well, there are going to be n minus 1. n minus 1, I wrote I there instead of 1. n minus 1 firms. Remember, that's all firms except firm I. Now, there are n minus 1 firms inside x super minus I. And then how much are those firms going to produce? Well, we know that their outputs are all going to equal xi. So that means that x, capital X super minus I, is going to equal n minus 1 all multiplied by x super I. Those two are identical quantities. Aha! Okay, so understanding that intuition, what does that allow us to do? That allows us to substitute in n minus 1 times xi into the best response function of firm I. And that's going to go into that second term here, where we have 1 over 1/2 times x to the superscript minus I. So let's go and do that. We're going to see what that does for us. So, we see here, I is BRF, x to the superscript I is going to be equal to p bar minus c all over 2 beta minus 1/2 of what? It's minus 1/2 of n minus 1 times xi. All right. So what can we do now? We have this 1/2 n minus 1 xi term on the right-hand side, and we're going to take that to the other side in order to collect terms. So what does that do for us? We're going to get xi plus n minus 1 times xi all over 2. And what is that all equal to? It's equal to p bar minus c all over 2 beta. Now we're left with the problem. On this left-hand side here, we have to make sure that we use the lowest common denominator, 2. So that means that we're going to have 2xi over 2 plus n minus 1 xi over 2, and that's still all equal to p bar minus c all over 2 beta. Alright, so what can we see is going to happen here? I've got 2xi, got xi over here, they're both over 2 now, and so I can take them over the same denominator. And so what is that going to leave me with? That's 2xi plus n minus 1 xi. That's all over 2, and that's equal to p bar minus c all over 2 beta. Okay. Oof. Now, what can we do here? Let's have a look at the left-hand side still. And we know that we've got 2xi and we've got n minus 1 xi. So I'm going to multiply those out so we can see what's happening, and I'm going to shift over to the next page. So let's do that now. Alright, so still with the left-hand side, I've got 2xi plus nxi minus xi, and that's all over 2. And that's all equal to p bar minus c all over 2 beta. Now what can we see here? If I've got minus xi and I've got 2xi, what is that going to become? That's just plus xi. Right? So that gives me nx. I'm going to write that more beautifully. nxi plus xi all over 2. And that's all equal to p bar minus c all over 2 beta. We're almost there, almost there. What can I do now? I can take out xi, as a common factor here. I've got xi over here, n times xi, and I've got xi over here. I take that out as a common factor. xi times n plus 1 all over 2 is equal to p bar minus c all over 2 beta. Aha! We're almost there. Now what do we have to do? If we can multiply by 2 over n plus 1, what can we see there? The n plus 1 over 2 over here would cancel out. And what would we have over here? Well, the 2's would cancel and we'd end up with n plus 1 in the denominator. So we're going to do that right now. We're going to see that xi n plus 1 all over 2 multiplied by 2 over n plus 1 is equal to p bar minus c all over 2 beta multiplied by 2 over n plus 1. And finally, what does that leave us with? Well, we're going to cancel terms. N plus 1 and n plus 1 cancel. 2 and 2 cancel on the left-hand side. That leaves us with a lovely xi, the output of the ith firm. What's next? Well, we can see on the right-hand side, what do we have? I've got a 2 and a 2. Those two cancel. And that just leaves me with p bar minus c over n plus 1. P bar minus c over n plus 1. That p bar minus c over n plus 1, what do we see there? Well, that is, I'm just going to make that slightly clearer. That is the output of firm I. And what do we know? Well, there are n firms in the industry. They all produce the output xi, and that is going to be equal to capital X. So what does that capital X equal? That's the output of all firms in the industry, and so therefore that is equal to n over n plus 1 all times p bar minus c. That is the total industry output. And that is the final thing that we were trying to see here at the end of math note 9.6 and the Nash equilibrium output for a firm. We'll also call this, you'll see, xn, that's the Nash equilibrium output in general for a firm, equal to p bar minus c all over n plus 1 times beta. Forgot the beta term there.